Okay, in this third episode, we will continue with the application of the multiplication and division law of indices. And we are continuing with this example 4 under that. And this example 4 is simplify 22n raised to the power of 7 divided by 2n raised to the power of 3. So I have 22n raised to the power of 7 divided by 2n raised to the power of 3. So the first thing I would want you to do in this question is just observe the question very well. If you observe the question, you will discover that the power of 7 is carried by n and not 22. So 22 is not an index number. 22 is an ordinary number. N raised to the power of 7 is an index number. Also, if you check this number or this expression, you discover that the power of 3 is carried by n. So n raised to the power of 3 is the index number, while 2 is the ordinary number. So the ordinary number here is 22. The ordinary number here is 2. So use the ordinary number to divide the ordinary number, and use the index number to divide the index number. So if we do that, what we've done is a kind of rearrangement. So what I'm trying to say is that use this number to divide the number in this expression, and use the number in this use the index number in this first expression to divide the index number in this second expression. So what we are going to have will be equal to 22, which is the number here, divided by 2, which is the number here, times n raised to the power of 7 divided by n raised to the power of 3. So what I did here is I rearranged the expression, or I collected like terms. 22 is a number, 2 is a number, so they can divide each other. N raised to the power of 7 and n raised to the power of 3, they are index numbers, so they can divide each other. So 22 divided by 2 will be equal to 11. N raised to the power of 7 divided by n raised to the power of 3. How would you divide it? You can divide it by applying the division law of indices. And the division law of indices states that s raised to the power of a divided by s raised to the power of b is equal to s raised to the power of a minus b. So if I apply this law in what I have here, since the root numbers are the same, n, I will take one of the root numbers, so that will be n, and I will subtract the powers, 7 minus 3. So 7 minus 3 will give you 4. So I have 11 times n raised to the power of 4. So 11 times n raised to the power of 4 is equal to 11 n raised to the power of 4. This is the answer. So just a quick recap. I have 22n raised to the power of 7 divided by 2n raised to the power of 3. So the first thing you should do is identify the number, the ordinary number, and identify the index number. 22 is an ordinary number, n raised to the power of 7 is an index number, 2 is an ordinary number, n raised to the power of 3 is an index number. So use the number to divide the number, use the index number to divide the index number. And that is what we've written here. We use 22 to divide 2, and we use n raised to the power of 7 to divide n raised to the power of 3. So 22 divided by 2 will give you 11, times n raised to the power of 7 divided by n raised to the power of 3, according to the division law of indices, is equal to n raised to the power of 7 minus 3. So 7 minus 3 will give you 4. So that will be equal to 11 times n raised to the power of 4. And 11 times n raised to the power of 4 will be equal to 11 n raised to the power of 4. So it's a very simple question. The example 5 as well is very much like the example 4. I mean, they are the same thing. And here we have 4x raised to the power of 5 divided by 4x raised to the power of 2. So the first thing you want to do is identify the number and the index number. identify the ordinary number and the index number. So in this expression, 4 is an ordinary number, x raised to the power 5 is an index number, 4 is an ordinary number in this second expression, and s raised to the power of 2 is an index number. So what you want to do is let the number divide the number and let the index number divide the index number. So if we apply that, that would be equal to 4 divided by 4, that is this 4 divided by this 4, times x raised to the power of 5 divided by x raised to the power of 2, that is the index number here divided by the index number here. So what we just did is we rearranged the expression. So after that, you cannot divide. 4 divided by 4 will give you 1. S raised to the power of 5 divided by s raised to the power of 2, according to the division law of indices. Since x is here and x is here, I will take one of the x and then subtract the power. So the power is 5 minus 2. So that will be equal to 1 times x raised to the power of 3. 5 minus 2 will give you 3. So 1 times x raised to the power of 3 will be equal to x raised to the power 3. This is the answer. 1 times any number is equal to that number. 1 times 5 is equal to 5. 1 times 6 is equal to 6. 1 times x raised to the power 10 is equal to s raised to the power 10. So 1 times any number is equal to that number. So that's how we got this 1 times s raised to the power 3 is equal to x raised to the power of 3. Okay, let's look at example 6. Example 6 is simplify 24 x raised to the power of 6 divided by 8 x raised to the power of 4. So this question is still the same thing as the example 5 and the example 4 question. They are similar. So but the difference is that this example 6 is arranged in a fractional manner, so we are going to arrange it in a linear form. So I have 24 x raised to the power of 6 divided by 8 x raised to the power of 4. So this is the same thing as 24 x raised to the power of 6 divided by 8 x raised to the power of 4. So just as we've been doing before, the first thing you will do is identify the number and identify the index number in each expression. So in this very particular expression, 24 is the number, x raised to the power of 6 is the index number. In this other expression, 8 is the number, is the ordinary number, while x raised to the power of 4 is the index number. So what I want to do is I want to use this number to divide this ordinary number. So that would be 24 divided by 8 times the index number here is x raised to the power of 6, x raised to the power of 6 divided by the other index number, which is x raised to the power of 4. So what I did here is I kind of collected like terms, but I like calling it a rearrangement. So I rearranged the expression. So after that rearrangement, I can now go further to carry out my division. 24 divided by 8 will give you 3, while x raised to the power 6 divided by x raised to the power 4. How are you going to divide it? You will divide it by applying the division law of indices. So according to the division law of indices, both root numbers are the same, so I will take one of them, that is x. Then I will now subtract the powers. 6 minus 4. So that will be equal to 3 times x raised to the power of 6 minus 4 will give you 2. So that is 6 times x raised to the power of 2. So 3 times this, 3 times x raised to the power of 2 will be equal to 3 x raised to power 2. This is the answer. It is very simple. So the first thing that you should do, or the most predominant thing that you should do, is be able to identify the number, the ordinary number, and the index number. So use the ordinary number to divide the ordinary number, and use the index number to divide the index number. So let's look at the last example, which is example 7 in this episode. And example 7 is simplify 27m raised to power 3 divided by 3m raised to power 2. So it's the same thing as the other example, that's the example 6. So what I will do is I will rearrange this fractional division in a linear form. So that will be 27m raised to the power of 3 divided by 3m raised to the power of 2. So the first thing you want to do is, first of all, identify the number and also identify the index number. So 27 is an ordinary number, m raised to the power 3 is an index number, 3 is an ordinary number, m raised to the power of 2 is an index number. So what you want to do is use the number, the ordinary number, to divide the ordinary number, and use the index number to divide the index number. So if we do that, that will be 27 divided by 3, ordinary number for ordinary number. So times the index number that we have there is m raised to the power of 3 divided by m raised to the power of 2. So what we did here is we rearranged the expression. So after that rearrangement, you can now start your division. 27 divided by 3 will give you 9. M raised to the power of 3 divided by m raised to the power of 3 according to the division law of indices. Since m here is the root number and m here is the root number, they are the same. So we will take one of the m, so that will be m raised to the power of 3, which is this root number, which is this power, sorry, minus 2, which is the other power. So this is just an application of the division law of indices. So that will be equal to 9 times m raised to the power of 3 minus 2 will give you 1. So m raised to the power 1 is still the same thing as m. And why is it so? It is so because according to the one index law, which states that s raised to the power 1 is equal to x. That means anything raised to the power of 1 is equal to x according to the zero index law. According to the one index law. So 9 raised to the power 1 is still the same thing as 9. 6 raised to the power 1 is 6. 12 raised to the power 1 is still the same thing as 12. So m raised to the power 1 is equal to m. So what I'm going to have here is 9 times m, and 9 times m is equal to 9m. So this is my answer. If you look at this question in a more caricature way, solving it is actually not something that is difficult. Let's say the question is 27 m raised to the power of 3 divided by 3m raised to the power of 2. So I can decide to kind of expand this expression. So this is like 27 times m times m times m. You know, m times m will give you m squared, times m again will give you m raised to the power of 3. So all over 3 times m times m. You know, your m times m will give you m squared. So you can decide to start cancelling from here, as in 3 here will give you 1, 3 here will give you 9. So, and m will cancel m, this m will cancel this m. So what you're having remaining is what? 9 times m, which is equal to 9m. So this is what you still have here as your answer. So if you do it like this, you are correct. If you also do it like this, you're also correct. But this is a more systematic way of doing it. So with this, we are done with the with this episode, and we're done with the application of the multiplication and division law of indices. In the next video, we'll look at application of the 1 index and 0 index law of indices.